What's up, guys? Do you want to calculate an infinite amount of genetic odds in your animals? Then stick around because I'm going to show you a simple way to do so. Okay, first of all, I know what you're thinking. My hair, my picture, it's all blurry. What's going on? Yes, I did cut my hair last night. My wife did not know about it. I did it while she was sleeping. I've been on this cutting hair spree with COVID and doing something different every week, and I haven't done something different in a while, and last night I was just itching to do something different. Originally, I was just going to keep the top, but then I started cutting down the sides, and I was like, you know what? It looks kind of cool as a mohawk. So I decided to keep the back, and now it kind of has like this mohawky effect. Anyway, let's roll some genetics here. Okay, so there's a lot going on here, but I'm going to explain all of it to you guys in a way that I think you're really going to understand and it won't be a problem. Each one of these Punnett squares, there's 5 of them here, represents a different gene that is inside the dad or inside the mom. You can see I've listed over here in the top right corner, these are the genes that are inside of the dad. Remember, DNA sometimes has thousands or tens of thousands of genes and genetic combinations inside of your body. Same thing within animals. So within the leopard gecko species, all of these different genes that I'm about to talk to you guys about today, they actually exist, and it's possible for all of them to be inside of one gecko at the same time. The dad's representation is on the top of the Punnett square, and the mom's representation is on the side. So the dad is a heavy hitter. He is an albino, represented by AA, eclipse, EE, white and yellow, represented by W and then N. He's only carrying 1 copy of the white and yellow gene. Blizzard, he's carrying 2 copies of the blizzard gene. And snow. And the mom is an albino, het eclipse, so carrying 1 copy of the eclipse gene. White and yellow, so carrying 1 copy of the white and yellow gene. Blizzard, snow. So do you see that? The dad is an albino eclipse, white and yellow, blizzard, snow. He's carrying all 5 of those genetic markers and mutations inside of his DNA. The mom, likewise, is an albino, het eclipse, white and yellow, blizzard, snow. She is carrying those 5 genetic markers or traits inside of her body. What is going to happen when you take the dad's 5 genetic traits and combine it with the mom's 5 genetic traits? Yes, madness. For this, you will most likely want a calculator. So I pulled up my handy dandy trusty calculator here, and I can show you guys all of the genetic odds that we are going to go through. Now, simply put, all you have to do is take the genetic probability of each one of these genes being passed down on an individual level and multiply that by every other different gene. Guys, what is the genetic odds of albinism passing down to the babies if the dad is albino and the mom is albino? The babies are going to be 100% albino. So 100% as a decimal is actually the number 1. So the first number in our multiplication sequence is going to be the number 1. We are going to multiply 1 by whatever genetic outcome we're looking at in the eclipse gene. So what do we want to do here? Let's first calculate the genetic odds of the baby being eclipse. Well, how many of these babies are eclipse in this Punnett square? If the dad is eclipse and the mom is het eclipse, how many of the babies are actually going to be eclipse? 50%. 50% is represented by 0.5 as the decimal. So going back to our calculator, we have 1 times 0.5 times, let's look at the next set of genetic odds here. We have white and yellow dad multiplied by a white and yellow mom. What percentage of the babies are going to carry 1 copy of the white and yellow gene? This is obviously a super white and yellow, which is a 1 out of 4 probability, but what percentage of the babies will carry the probability of carrying 1 copy of the white and yellow gene? 1, 2. 2 out of 4 is 50%. Again, add that into our multiplier. 0.5 again, multiplied by the blizzard probability. So if the dad is blizzard and the mom is Blizzard, what percentage of the offspring are going to be Blizzard? 100%, which again is represented by the number 1. Multiply that again by the very last genetic trait that we are working with in this calculation, which is snow. Now here is a super snow, but what percentage of the babies are carrying only one copy of the snow gene? 1, 2, 50%. So our last genetic calculation will be 0.5. And what do we get here? We get 0.12, which is actually 12%. 0.12 multiplied by 100. That's how you reverse that decimal, change the decimal into a percentage, and you have 12%. So what does that mean? That means that 12% of the babies will be calculated according to the odds that we chose. What did we choose? We chose albino is 100%, eclipse is 50%, white and yellow carrying one copy of the gene is 50%, blizzard is 100%, and snow carrying one copy of the gene is 50%. 100% times 50% times 50% times 100% times 50%, you get 12% of the babies is going to be an albino, eclipse, white and yellow, blizzard, snow. So you took the 5 genes of the dad, combined it with the 5 genes of the mom, and we just calculated that 12% of the babies will be that specific genetic outcome. Now let's do one more example, just so that you really get it. Let's look at the super form of the white and yellow and the super form of the snow. Okay guys, so answer along with me here. What percentage of the babies are going to be albino in an albino to albino pairing? Yeah, you got it, 100%, which is represented by the number 1. You take 100%, move the decimal place over 2 places to the left, and there you have your multiplicative number. Now, what percentage of the babies are going to be eclipse? 2 out of 4, 50%, which is represented by 0.5. What percentage of the babies are going to be super white and yellow? Remember, carrying 2 copies of the white and yellow gene. That's going to be 1 out of 4, which is 25%, or in decimal form, 0.25. What percentage of the babies are going to be blizzard? 100%. So that's represented by the number 1 again. And the last multiplicative number that we're talking about is how many babies will carry 2 copies of the snow gene. So how many of the babies will be super snow? 1 out of 4, which is represented by 25%. So let's multiply that by another 0.25. Ooh, now we're getting really low here, right? So the first genetic outcome that we chose was a 12% chance that the baby will be albino, eclipse, 1 copy of the white and yellow gene, blizzard, and 1 copy of the snow gene. But what probability of babies will be albino, eclipse, carrying 2 copies of the white and yellow gene, blizzard, and carrying 2 copies of the snow gene? Right here, we did our genetic multiplication, and we have 100% times 50% times 25% times 100% times another 25%, and what you get is 0.03, which if you multiply by 100 and move the decimal over 2 places is actually 3%. So 3% of the babies will be albino, eclipse, super white and yellow, blizzard, super snow. Do you guys see how that works? And for any genetic probability that you're interested in, you can also do the multiplication out for. For example, all the genetic possibilities within this box are the same because the only genetic possibility in this box is albino. But you have 2 different genetic possibilities within this box. You have eclipse genetic possibility and you have het eclipse genetic possibility. And when you move on to the white and yellow box, you have 3 different possibilities in this genetic box that could get passed on to the offspring. You have the super white and yellow, the regular white and yellow, and the completely normal. So based on what you're looking for, you have to do the multiplication odds and pull out that percentage from each of these boxes of the genetic trait that you're trying to calculate at that very moment. The blizzard, again, it's all the same genetic odds. 100% is going to be blizzard. And the snow, again, is going to be 3 genetic possibilities: the super snow, the regular snow, and the normal. All right, guys, so I hope that helps a little bit. It's going to take a little bit of time, but rewatch this video. That's what I did when I first started learning. Was I just got super into it. I just started watching videos, rewatching it. Do the mathematical calculations yourself. See if you get the same calculations I got. And if you did, then you know that you're on the track to success. So thank you for watching another one of my videos. Stay tuned because this is going to be a big week for Geeky Gecko Creations. Tomorrow, which is Wednesday, December 9th, I am going to do a live stream unboxing of a special snake. I just ruined it. That we are working with here at Geeky Gecko Creations. And then Thursday, if you're in it for the geckos, you will definitely want to tune in Thursday because that is when we are going to be revealing our brand new, super huge, big, gigantic, ginormous project that we are going to be working on here at Geeky Gecko Creations. And I bring a guest along and announce his role in the project as well. So thank you guys for tuning in. Check out this outro. Love you guys, and I'll see you in the next video.